All right, good morning and good afternoon to our global audience. Welcome to today's webinar on All Graph Databases Are Not Created Equal. Welcome this morning, Amy Hodler and Amit Chowdhury.
Pleasure to be here. Thanks.
Thank you, Lance.
All right, well, I'm excited to cover this topic with you guys. So let's kind of start at the start. So Amit, you wrote the paper. Talk about kind of what's happening in the database market such that the market would really have any need for a graph database buyer's guide.
Great question, Lance. So one of the things that we have been observing over the last few years is that graph database market, or as a category in general, has been increasing very rapidly. Database engines, which is kind of a bellwether for determining how the database trends are.
This is the DB Engines website.
This DB Engine, sorry,
Okay.
yeah. They are looking at graph database as the fastest market since 2015 or so. And rightly so, because what is happening is that what graph databases do is that they prioritize the relationship between the data sets. So the companies are now finding this extremely valuable to determine how two data sets are related to each other and what knowledge they can get out of it. The other pieces is that the difference with other databases is that when you think about consistency, performance, scalability, and things like that, graph databases tend to behave a little bit differently. So trying to sort all that information out was getting a little bit more complicated. So we figured that it would be better to put together a buyer's guide that kind of lays these things out very clearly, so that the developers and the users can find the information they're looking for and determine what kind of a database they need for what kind of requirement.
Okay. Makes sense. So you touched on a couple issues. You mentioned, for example, performance and scalability, and I think maybe there's some vocabulary here in that, the word database has been around for a long time, and just I would imagine the vast majority of people listening to this webinar have experience with one, if not multiple, database platforms. So I think there are a lot of assumptions that come along with that. The same way when somebody tells me they bought a car, I think 4 wheels and a steering wheel and the things I'm used to. I think people have a lot of assumptions around databases. What can you tell our audience in terms of what assumptions hold or don't? Where are the differences and gaps among graph databases?
Yeah, I think let me take that analogy that you brought about when you talk about a car is four wheels and a steering. Let me expand that analogy to say when you talk about an automobile, there's a car which also has 4 wheels and a steering, and maybe a pickup truck which has 4 wheels and a steering, and it's used for a different purpose and things like that. In that context, if I draw that analogy between databases, the older technology, which is relational databases, and maybe a little bit newer NoSQL databases, they prioritize on collections, whereas graph database prioritize on connections. So that's the big difference between collections and connection. Let me actually expand that a little bit. The relational databases have been doing a fantastic job for the last 40, 50 years. They came at a time when the data sets were fixed and they had to be put together. That's why the collections became more important. However, they are not suitable for today's market where the data is where the velocity and the volume of data is extremely high. The prioritization is more on the reads rather than the writes. And the agility factor and the connection factor is missing. The NoSQL databases try to do that a little bit better. They created APIs, the developers started finding it easier to work with. But the challenge with the NoSQL databases is that they ended up giving up on the data integrity part, because the consistency of the data was eventual, and sometimes that became a challenge for some of the use cases. Databases, on the other hand, are prioritized on the relationship between the data, and they find the value between those data sets. In a lot of ways, graph databases mimic the human brain. So if you think about a human brain, you have neurons which are connected by synapses. In graph database, we have nodes which are connected by relationships. And so what happens there is that these databases are uniquely set to find these relationships, and in those places where you do not know what the relationship needs to be, the graph database actually is able to find that out. So that's the uniqueness of what graph databases bring to the market, and that's why they're becoming more popular and popular today.
Okay, so one of the things you hit on then was kind of data integrity in a transaction environment, and there certainly are a lot of graph applications that are transactional. But Amy, I wanted to turn to you and talk a little bit about, graph analytics seems to be a topic that is getting more attention over the last couple of years. And before we dive into it, can we just give people kind of a definition? What are we talking about when we talk about graph analytics?
Yeah. Well, so to contrast with transactional, in the transactional world, you're usually trying to make a very local, real-time decision. Do I approve this application or this purchase for this particular thing at this particular time for this particular person in login? So real time becomes very essential for that. But it's very local in what it's looking at. It's looking at things connected usually to that person or account. When we talk about graph analytics, it's usually more holistic. So you're trying to analyze your network in total. So you might be looking for things like what's the most influential node in the network. And analytics has a tendency to look at three different major areas, or the kind of questions. Is what is the overall structure of my network? What is the flow from one end to the other? What's the optimal flow? What are the communities within my network? So I don't necessarily know ahead of time exactly what I'm looking for, but I'm looking for some kind of structure. Now, what's really interesting is we're seeing graph data science explode. And you can think of graph data science as just taking graph analytics, and as opposed to just looking for particular structure right now, that you might be looking for predictors of things in the future. And so using things like graph analytics to pull information out and then do machine learning on that right now.
Okay, so let's kind of double click on that. In that, you mentioned that when it comes to graph analytics, people are kind of asking a different kind of question. Something that's a little bit more holistic, something that's a little more sort of aggregated or summarizing what we can learn from the data, sometimes in an AI context. Can any graph database do that? I mean, what's required from a technology perspective to really support those use cases?
Yeah, so there are things that can be done, and then there are things that are not practical, or practical depending on how your database is set up. A couple of things that Amit talked about as far as the structure and how we store things, and storing things with the index-free adjacency, so you're always just one hop out, makes it much easier to do complex queries, so that you can query very easily around a particular entity. So it's having that structure makes that more efficient, so that's important. But one of the things that I think is extremely important, that I think a lot of people don't think about until they get into graph analytics, is this idea and this way to transform the data that you have and however you have it stored from one format to one that works really well for these global computations. So if you can imagine a large network of data with a lot of different connections, maybe you have some supernodes, maybe you have some complex relationships, computing over that can be really expensive. And so being able to transform into a shape that is very efficient for computing is really important. Being able to do it in a way that the user doesn't have to get involved is supremely important. I can't imagine having to do a transform each and every time I wanted to run different type of analysis. So that's something to definitely pay attention to.
Okay, makes sense. Let's talk a little bit about kind of the users of graph databases. So, in today's market, developers seem to be the ones who are most aggressively adopting graph databases, and so we tend to be talking about people who are pretty technically competent, excellent. They're comfortable experimenting. They've been working with NoSQL platforms for close to a decade, kind of stretching these things into different use cases and shapes and sizes. Why can't a talented developer just kind of grab any graph database and make it do what they need for their application?
Excellent question, Lance. I think just to kind of do the level set, that of course the developers can pretty much do everything. They can play around with different databases. They have been tweaking it for a while. They have been extending, and they've been finding new use cases and things like that. But in the graph database, it's not very different. Most graph databases today do provide something that the developers think as a baseline: redundancy, consistency, the ability to have the ability to write the application easily. But there are still certain factors that are different for Neo4j, for example, which are unique and distinguish itself from the other graph databases. One of this is about a GQL, or a graph query language. We talk about SQL as a query language that was written about 30 years ago, and writing that SQL as a query language basically propagated the usage of relational databases for the last 30, 40 years. In that case, we have to think about what is the query language for graph that is available today. What is more popular? There are many different query languages, but one or two are the more distinct ones, which is essentially what developers would like to adopt, because then you can write your applications across from an open source perspective and things like that. Number two, you have to think about the tools. When you're moving from an existing database to a new database, one of the key things that everybody is looking at is that how easy it is to write to that database, how easy it is to ingest the data from a different source into that database. And in case of Neo4j, we provide certain tools like Kettle or certain ETL tools, what we call that, and the ability for us to ingest the database is much easier. And then you have to also think about, if I am, do I have some adaptive tool to do some data modeling before I actually move into a production database? And Neo4j has what we call as a desktop environment that allows them to natively actually build a graph database that has got all the descriptions and things like that for a developer to actually build a data set, and then you can import that into your production database. There's also certain concepts of visualization, because what visualization today is that it allows the propagation or usage of graph much easier. So the ability to be able to visualize what you're doing in a graph pieces is also important. And we have a tool called Bloom that essentially allows you to do that. So yes, it is easy to use any graph database, but if you have some of these criteria, the ecosystem of these technologies that make it into a platform, if you will, allows the developers to experiment with it much easier, and also makes it easier for them to use it in a scalable way.
And I'd also say, adding on to that, we've got a really passionate community.
Oh, that's right.
So, so that if you do have questions, we've got community website. We've got people that are very active on GitHub that are also sharing their experiences and the tools that they're building as well.
That's correct. And I think I forgot one point on that. The algos is also a thing that graph databases also have it. You talked about graph analytics in general, and the ability to have some of those incorporated within the database is also important. So that's what developers are looking for.
Okay, cool, makes sense. So I heard community, I heard query language, I heard development environments, and then I heard tooling for things like visualization, getting data in and out.
Correct.
Things of that nature. Okay, makes a lot of sense. And then another user community that seems to be coming on more recently, Amy, is data scientists. They seem to be showing up at the graph party in kind of big numbers compared to a couple years ago. If I'm a data scientist and I'm thinking about, taking advantage of graph for some of my use cases, first of all, what are those use cases, and what do I need to think about in my graph database so that I can effectively support them?
Yeah, so I would say in the data science world, a little different needs. They need to try and experiment a lot. What we see, the biggest use case in data science is machine learning. So you basically use the graph algorithms to do feature extraction, basically extracting out your predictive elements of your data and then feeding them into your current pipeline. So having something that supports and a company that has experience with that pipeline is very important. The other thing is having lots of different algorithms in a library that are pre-written for you. So you can go and pick up a research paper and try to implement your own. I wouldn't recommend that, and you certainly lose some consistency there, as opposed to having a library where you have quite a few algorithms. I think we're over 40 now. So we have one of the largest sets in an enterprise environment of algorithms that are supported as well, and that they scale. So, having a small data set, you might be able to perform some very interesting analysis, but once you scale out, that can be difficult in a lot of platforms. So looking for something that is supported up to billions of nodes is something else that you should look for. The other thing that might be might not be apparent at first, is just having a common syntax that's easy to understand, clear error messages, and ways to share, like with visualizations you mentioned. How do you share what you've analyzed with your line of business manager or your business? You need to explain some of these.
Yeah, this is kind of demystifying the black box to say, hey, here's what's going on, and here's why you're getting what you expect out the other side of it.
Exactly.
Okay. Amy, I want to pick up on something else that you mentioned, and I'd love your comments as well. Amit, you touched on the notion of community and the fact that because Neo4j is open source, there are a lot of experts out there who people can collaborate with and such. Let's build on that. What are some of the other, if I'm a developer and I'm thinking about choosing a graph database, one might be open source, one might not be. There are multiple flavors that are open source, multiple that aren't. What other considerations beyond that community? What else should I think about as a developer if I'm looking at why I might choose open source?
Yeah, so I think the community support is one, but also having a partner ecosystem that has also been contributing to the open source and to the community in general. The other thing to really think about as well, and it might not be apparent when you first start working with graphs, is the skill sets that you're going to learn or you're going to have to hire for, are those going to be skill sets, whether it's Cipher, understanding a native graph database, understanding algorithms? Is that something you're going to be able to apply later on in your career? And if you're hiring for that, how easy is it going to be able to find the experts that you might want to bring in as well?
Yeah, just to add to that, I think the open source also allows a lot of flexibility. From an enterprise standpoint, if you're building your applications on an open source environment, you have the ability to move these things around. You don't get locked in. There's no vendor lock-in with open source. And like Amy talked about, purely from a community standpoint, if graph, this is a newer technology, and as we are moving towards that, the ability to have a support of the community is extremely important. As well as the fact that it attracts a lot of talent. Otherwise, if you're a closed source company, a lot of people don't really want to be in a situation where you're not expanding your horizons, or you're not learning something new, and you're not able to get the support from the community. So that's why open source is becoming important. And from our standpoint, if you think about Lance, there have been very, very few companies that have actually been successful in the closed source. Oracle and Microsoft, but that was many, many years ago. In today's world, open source is the way to go, and most of the people are looking for open source designs.
Yeah, it makes sense. I mean, you've certainly seen some of the big vendors that you've mentioned embrace open source in different ways. Okay, makes sense. I want to double click on a key point here. Amy, you mentioned some of the large configurations when somebody's modeling, for example, a large telecommunications network or those sorts of things. Graphs tend to be pretty data hungry. We've seen customers who get going, the light bulb goes on, they get success, and then they say, okay, we want to deploy more use cases, we have more data we want to put into graphs and such. So scale becomes an important consideration. Yeah. What can you tell our audience about how to think about graph scalability as they consider some of the alternatives out there?
Yeah, so Neo4j scales out for reads, so we can add in more instances, so you can scale out your reads and access. And then for writes, we scale up. We've got quite a few very large customers. We've got some of the largest, banking organizations, financial institutions. We also have companies like Adobe who have used Neo4j in the Behance platform to go from 150 MongoDB instances down to 50 Cassandra, and eventually down to Neo4j 3 instances. So it's interesting when you think about scale. A lot of people just think, if you got that means big and out, and it also means how do you compact your data such that you can scale your data without having to have the large hardware. So it's not just about the hardware; it's about what's your structure as well. And Neo4j has a very compact data structure that allows us to add a lot more scale from the data without requiring all the additional instances and hardware that you might with other solutions. So it's a little counterintuitive sometimes, but it's just like your phone in your pocket. The computing power you have in your pocket is by far greater than what they use to put man on the moon. Yeah, exactly. And so handling millions of relationships per second from a processing standpoint is no problem with Neo4j, and billions of nodes for analytics is no problem either.
Okay. All right, good, makes sense. Let's talk a little bit about security. Amit, so how does a graph database like Neo4j handle security?
So security is extremely important. It's a database, it handles people's data, and there are liabilities and other issues that are connected with that. So, we take security extremely seriously. So there are obviously very key and basic set of security parameters that we follow. So user access, every user has to be authenticated and authorized. So we provide authentication and authorization. The data is encrypted both at rest as well as when it's traveling between nodes. Our databases are obviously integrated with LDAP as well as Kerberos. That's one of the standards that everybody, in fact, are looking for, which is the enterprise grade level security. And in a lot of ways, we are also working towards providing finer grain access to where security is available at the node level rather than at the overall database level. And those are different, that's required for different use cases. So we will be in a position to offer that in the upcoming releases. But some of these are basically what we call as are table stake security, but also important within the graph world is that how do you provide access at the node level, how do you provide access at the user level, and how do you make sure that the security parameters are integrated across the broader enterprise frameworks that the companies have. So we have all those levels of security provided in Neo4j.
Okay, got it. Amy, so Amit touched on DB engines and such, and kind of from a couple of angles. One being that graphs as a category are getting more and more popular, but also Neo4j is kind of ranking in the category. So people can check the numbers online themselves, but that doesn't really tell the story behind it. Let's talk in a nutshell. What really makes Neo4j the leader in the graph category?
Well, I think there are probably several different areas. I was having a conversation with somebody the other day and said, well, we've done the less sexy, boring work over the last 10 years, where things like how do you structure your data model properly? How do you make sure that you can seamlessly transfer to do computations? The security that you mentioned. So I think there's a lot of history with doing maybe the less sexy work, the foundational stuff that needed to happen. And then I also think a focus on users and developers and data scientists is making it easy and intuitive, which is everything from having a rock star developer relations team to having a strong community, to having an ecosystem that we play very well with and within, and supporting things like the GQual standard. So I think it's all of those, doing all of those things right, and doing them with the intent to how do you increase graph to help people make sense of the data.
Yeah, I'll just add a couple of more points to that. I think, first of all, Neo4j is obviously the category leader. I think you talked about the hard work. We kind of built this category, and now we're pushing this category to become more mainstream. So it's not just looking at graph-centric use cases, but looking at every use case that could basically be solved by graph. So I think we are working in that direction. Amy talked about partners. Amy talked about the ecosystem, which includes the partners and things like that. And we talked about tools earlier. You need the tools that basically allow you to ingest the data, visualization, and things like that. One of the other key things that I want to talk about is the professional services organization. It's as much important, if not more, about how do you actually implement some of these things at the enterprise level. And we have a growing at a very dedicated and I would say very smart and intelligent professional services community that essentially is helping customers evolve from their existing data structures to a graph data structure and doing some successful projects. So I think all in all, nobody has invested that much amount of capital, both resources as well as human capital, to be able to make this as a mainstream business. And I think Neo4j is the leader in that respect.
That's a great point. I think there is no company that has this many resources focused on graphs. That's all we do.
That's right.
We do it well, and everybody's very passionate about it.
That's
so,
right.
And that really propels us to keep setting the bar higher and higher for ourselves and for our customers too.
Okay, good. Makes a lot of sense. One of the things that comes up a lot, you hear it in the Neo4j vocabulary, and people ask about it, is this concept of a native graph database. Can we go a little bit deeper on that? What does it really mean? Because there are lots of different graph database flavors, some native, some non-native. What does it mean to be a native graph database?
That's a great question, and I think it's something which is very important for us when we talk about your earlier question of not all graph databases are the same. In fact, there are two kinds of databases. One is the native graph databases and non-native. Let me touch native graph a little bit differently. But non-native, there are two categories. One is that somebody has a graph API on a data model, which is basically non-graph. And then and the second category among them is that they are multimodal, and therefore they have the same data set could be used in different ways. The native graph in general is where your entire stack is basically designed to solve a graph problem. So right from your file structure to your database management engine to your APIs to your ability to actually print and analyze data. So the entire structure is native. Now the advantage for that is because of the way it is designed and where the storage, native storage is what essentially is what makes it the key for somebody to be able to do a native graph, is that the performance and efficiency is extremely high. So performance is the ability to solve the problem. The scalability, which Amy talked about, billions and millions of nodes and essentially making sure that your data data integrity is maintained across the structure is high and efficient because you can run massive scalable architectures on smaller machines. And that's what native graphs do. Neo4j is a native graph database, so it allows us to be able to expand, scale up and scale horizontally to be able to solve the problems. Non-natives are not in a position to do that because you need to have the ability to convert your non-graph data set into a graph data set. So that requires a lot of computational capability, and therefore they're not in a position to be either that high performant or scalable or efficient. So that's the big difference between a native and a
And I
non-native.
think about with the non-native a lot, if you think about answering a complex question which has different relationships, if you haven't stored your data
That's right.
with those relationships, every time you make that query, you're having to do an index lookup and a join and a join and a join and a join potentially.
That's right.
And just as opposed to having that information already there and you're just querying it, you're actually having to put that together, so you take a hit every time you do that query.
Yeah, and one last thing I forgot to mention, just to add to what Amy said, is that these abilities to be able to find these joins and kind of putting it together, the chance of data becoming corrupted is extremely high. And I think that's one of the risks that you associate, perhaps not at a smaller scale, but when you scale those things out, the data corruption becomes extremely high. The chance of data corruption is extremely high in a non-native graph database.
Okay. Makes sense. So one of the things that I think the market is seeing, and certainly Gartner wrote about recently, was how a lot of data management is really moving to the cloud. This has not just started. This has been happening for a few years. Amit, can you talk a little bit about what are some of the options if somebody's interested in Neo4j and wants to understand, available options for running it in the cloud?
Yeah, so that's a great question. So let me talk a little bit about what are the great options of experimenting with Neo4j, both on-premise as well as in the cloud in that scenario. So we offer, I talked a little bit about Neo4j Desktop. So basically, it's a desktop version of our graph database that offer limited capability that you can basically download on your desktop, experiment with it, use with it, and see how that goes. And once you're ready to move it into production, you can actually just move your data right across into the database. That's number one. We also provide sandbox environments. Sandbox environments is essentially where you can consistently keep experimenting and making things as well. And we offer that in a manner that is very non-disruptive for developers who are looking for them. And last but not the least, we are also going to be coming out with a database as a service that essentially is designed for the developers who want to really experiment and who want to really understand how people should use or how Neo4j can be used. The good thing about this database as a service is that it's pay as you go. It's a consumption based, so you don't really have to pay upfront to be able to use it. So you can, we build it on a monthly basis and you can use it, and then, and you essentially pay for what you have used. So those are the three different ways that we allow, or we're going to make it easier for developers. Our goal is to democratize graph usage, and therefore we feel that these are the three different ways we can help more and more developers actually using Neo4j graph database.
Okay, makes a lot of sense. So multiple different paths to understand that. Okay, great. And then one other question, you mentioned, Amit, you touched on GQL. Amy, you mentioned the Cypher query language. Can we, for people in the audience who aren't familiar with those terms, can we help explain what that means and why it matters?
Yeah, so GQL is what basically stands for Graph Query Language. A graph query language is something that is a declarative way for people to understand how to use graph databases, because it allows them to learn it well. The developers essentially can learn it easily. You can read and you can edit and essentially do that. Now, the most important part, it's a little bit of a history that has been made, Lance, if I may say. If you think about what SQL or SQL did about 30 years ago, is that I love using this word. It democratized the usage of relational databases across, because it created a standard. It was, you write to SQL, you can basically use any database. So GQL in that respect is exactly what it is. After 30 years, the ISO, the standards body, has accepted GQL as the standard for graph query language. And I'm proud to say that Neo4j Cypher is a huge contributing factor in that part. We have been running Cypher as an open source query language for many years. We discovered it, we invented it, and we have contributed now with some of other partners who took Cypher and they started looking at their own different ways. We open sourced, right? So most of the partners actually took Cypher, they started using it, and the popularity became so much that the standard body basically started recognizing it, and now everybody is working towards, or everybody worked towards making it as a standard for query, graph query, and that got accepted about 4 weeks ago as a standard graph query language.
And just to be clear, it's actually a standard graph query language project right now. So
Right.
if people still want to participate, get involved, have feedback, they can work with the ISO body and that project
That's right.
to continue to evolve
Yeah,
that going forward.
And the advantage for that is about the ecosystem that it's going to propagate. Right from ingestion tools to visualization tools to the the processing and things like that. Imagine how SQL kind of created this massive ecosystem of different companies who created products around the database. That's what we believe that GQL is going to drive, and it's already a huge momentum about partners actually creating these products.
I think that's a good point about the momentum is we have Cypher, which we use internally. There's Open Cypher,
That's right.
Which people can go and Google and look at the Open Cypher resources as well, that leverages the Cypher kind of framework in an open way.
That's
and
right.
there's, I believe, 7 different products that actually use Open Cypher as well. And so it's a nice precursor to say, what does it look like when we start to open source and have a declarative language that many people can use in different products, and what GQL could bring in the future, like we've done with Open Cypher.
Absolutely. We are very excited about that. It's a history that got made 4 weeks ago, and I think all of us should be very looking forward to making that as a huge success.
Okay, so if I'm a buyer, then if I look forward, then so this project of GQL has been blessed to move the space towards an open standard, building on some of the work that Neo4j and others have done around Cypher and Open Cypher, and some of the best of some of the other query languages out there, including some SQL extensions and such. But I guess if I'm a buyer, then I look forward to a market down the road where, like you said, Amit, tools are interoperable, skill sets are portable, applications are portable. So it feels like a big win for me as a buyer. If the vendor community converges around a standard, I get a lot of benefit.
Absolutely.
I think it's a big win for the graph environment overall.
Yeah.
No one single vendor, but the whole graph community, I think, is a big win.
Yeah.
Okay, very good. Well, that's a nice note to wrap up on. So let me suggest to our audience, if you are interested to learn more about Neo4j, I would suggest if you're on the IT side, or maybe you're an application owner or somebody who is looking at business requirements, I would strongly recommend the Intro to Graph Databases ebook if you want to just understand graph concepts, if that's new for you. Or I would strongly encourage you to, if you're more serious and further along in your education, to take a look at the Graph Buyer's Guide. It goes into a lot of detail on the subjects we covered today. And if you're a developer, there are also some great books on ebooks on moving from relational to graph database. So if you kind of have all your relational concepts and you want to translate it to the graph world, it will help you there. Amy published a book recently on graph algorithms. It's been very popular, so if you're thinking about data science use cases and such, definitely take a look at that. And then finally, back to Amit's comment about easy ways to try out Neo4j. If you want to just put everything on your laptop and do your thing as a developer, there's Neo4j Desktop. Or if you want no download, just try things out in the cloud, play around with sample data sets, we would point you towards Neo4j Sandbox. But one way or another, we hope you look to learn more about graphs, learn more about Neo4j at neo4j.com, and we thank you for attending today's webinar.
Thank
Thank
you,
you.
Lance.
All right,
Thank
thanks,
you.
guys.